The last thing we need to learn how to do in integration by substitution is to do something called change of variables. We're going to start with actually doing a problem that you've done before. And then what I'll do is take you through the new process of change of variables. So just to review, go ahead and try this problem yourself. Go through the steps of finding u and du, and then don't forget, in this particular problem, you have some numbers to substitute in. So in other words, there shouldn't be a plus c in this problem. Okay, here's the answer. So check your steps. U should be x squared plus 1, du is 2x dx. So you just had some slight manipulation to do by a 2 in the back of the problem and a 1/2 in front, and then finally add 1 to the exponent and divide. Remember, in this one, you had to substitute the numbers 1 and 0 in. So again, the final answer is 15/8. We'll come back to this problem in just a few minutes. So let's look at this new process first. The idea is when we use something called u substitution, what you're going to do is actually integrate it with the variable u instead. That way, we don't even have to do any conversions. So let me explain this. It's a little hard sale just to get you to understand why this might be necessary, but I think you'll see later on when we do a few sample problems how this process can save you some time. So let me demonstrate this new procedure of substitution by change of variables. The first thing we want to do is to go ahead and set up the same way you would have before with a u and a du. So I'm going to move that x squared back to the back of the problem. Here, u is equal to 2x cubed plus 1. So du should be 6x squared dx. All right, so I'm going to need a 6 at the back of the problem and a 1/6 in front. In the past, when we did these types of problems, you would go ahead and start the integration process. But instead, we're going to do u substitution. So I'm going to do substitution everywhere in this problem. Let's start with the 1/6. 1/6 really can't be changed, so I'll put that here. However, there can be a substitution for this part. We now have a variable that represents 2x cubed plus 1. That variable is u. So instead of writing 2x cubed plus 1, I'm going to write u. It just so happens that u is squared in this problem. The last part, instead of going ahead and just getting rid of it, I want to go ahead and do a replacement. 6x squared dx in our problem is the exact du. So I'm going to go ahead and do a substitution and write du in its place. At this point, we've done a complete change of variables. So let me go ahead and jot that down. Change of variables. Now, if you think about it, I really haven't done any calculus yet. All I've done is just completely changed what's written. So now we'll do the calculus. I'm going to add 1 to the exponent and divide. This will be u cubed over 3 plus c, or 1/18 u cubed. The problem is this isn't the answer to the question. The question had x's in it. So I need to go ahead and do one last substitution and convert this back to what it used to be. That means everywhere you see a u in this problem, we're now going to convert back to what u actually equals. That's 2x cubed plus 1. And remember, that was cubed in the problem. This is the same answer we would have gotten if we'd used the other technique. Now again, I know it's a hard sale. Why would you ever want to do this? And to be honest, at this point, I probably wouldn't do this unless somebody forced me to. The convenience is going to be when we go to definite integration, when there's little numbers. But let's just stick with it, work with this process, get pretty good at this, and then we'll switch over to a problem where that'd be much more convenient. I want you to try one like this next. See if you can use the same example to go through a problem on your own, the whole way through to the conversion. So try this one yourself. Remember, you need to move that 3x plus 5 to the negative 3 up to the top. All right, here's the solution. Check your work to make sure you've done it exactly the same way. The next thing we need to do is look at a definite integral. So here's a new one, the integral from 0 to 1, x squared plus 1 quantity cubed. This problem should look familiar. It's the very first one you did. We're going to try it with this new process of integration by substitution. So I'll start the same way you would have done earlier in this presentation. U equals x squared plus 1. So du should be 2x. Means we need a 2 at the back and a 1/2 in front. Okay, I think it's ready for U substitution now. This is equal to 1/2 the integral of U cubed times du. The only thing is, I can't write the 0 and 1 there. So this is something different we're going to have to do. I need to do a conversion. In the problem up at the top, I have 0 as the lower limit. This is representing what x equals. I need to convert this to u to do a complete change of variables. So if x equals 0, I'm going to jump over to the formula. U would equal 0 squared plus 1, or 1. Let's do the same thing with the upper limit. If x equals 1, I'm going to jump over here and convert it. 1 squared plus 1 would be 2. This is a complete change of variables. Sometimes in multiple choice questions, you'll actually stop at this point. Kind of interesting. We haven't really done the problem. You don't have an answer to it, but it's a complete change of variables at this point. Okay, but let's keep going on this one, see if we can get the answer. I'm going to integrate, so add 1 to the exponent and divide. Remember though, this isn't a plus c, it's from 1 to 2. So this would be u to the 4th over 8 from 1 to 2. Now just substitute the numbers in. I'm allowed to do this just because these are both u's. 2 to the 4th over 8 minus 1 to the 4th over 8, which is 15/8. Check your work from earlier when we first started this presentation. This is the exact same answer. This was all made possible because of switching these numbers. We didn't even have to go backwards and convert it to x's. Since we converted these numbers to u's, everything should work out perfectly. So this is the key. This sometimes will save you a lot of work. Unfortunately, we don't know ahead of time when that's going to happen. So we'll practice the process, and for testing purposes, what they'll do is they'll actually tell you which method to choose. All right, I'm going to have you try one problem like this, where you convert the definite integral and the integration limits. All right, try this one on your own. Remember, just like before, you'll need to move that square root up to the numerator in order to integrate. As soon as you're finished, go ahead and push play to see the answer. All right, here's the solution. Square root of 28 minus 1. Same answer we would have gotten had you have done the regular process, but now with this conversion, it provides a little bit of efficiency that you don't have to go back. I went ahead and circled put a yellow square around the part, the U substitution. I think it's important just to at least note, most of the time on tests, this is where you would stop. You'll see in some sample multiple choice questions that we look at in the next few days, they'll give you these as solutions, just to check to see if you can do the procedure. Because if you think about it, in a multiple choice question, since we get the same answer no matter what, they really have no idea how you're actually doing the problem. So this is the way they test that. So at this point, we've actually looked at all the different methods and techniques of integration by substitution. So what we're going to do over the next few days is practice this, and then remember, we're going to have a quiz at the end of the week.